Hi, I just received this XP Pen tablet, and in this video I'm going to show you just a few things as a math teacher. I have been using a Wacom tablet for many years, and this is a far more inexpensive and it's far wider area, and it has a whole lot more hotkeys there. So that's why I purchased it, and it looks great. It does everything I wanted. So this is the model I purchased it there, Star 03V2. It has all these explicit keys and looks great. So I'm just go ahead and screenshot this one and show you, what I do every time I give a lecture using this device. And this thing is called GIMP, the software I'm using to do this. Pause it. All right, I managed to make it a little bit bigger. This is happening in the GIMP system. Again, this writing area is a 10 by 6 inch. The earlier Wacom tablet I compared that with this just writing area part. It was nearly just half of this height part and nearly half of this width part. So that was pretty much what I could write with a bamboo tablet. As you can see, 2 times and 2 times is 4. So in terms of area, this is a 4 times area. I'm enjoying it here. That's one of the reasons I tried this one, and it had, again, 2 times the number of the hotkeys I could use in the Wacom tablet. And this is a 5th key, and as you can see there are 8 keys there from this XP pen. And this is the driver software it came with. And if you go down there, look at the XP Express hotkey. So you can see there are 8 keys you can set up and individually, and these are all the shortcut key I set up in this GIMP system. So since I'm using the GIMP system, that's how it's set up. And also I played a little bit with this pressure sensitivity part in there. Realize that this machine I didn't use that much before with the Wacom tablet. This one, harder pressure was better for me. So with that one set up, and I could write it really easily, especially because of the wider area. It's absolutely easier to write things small. For example, don't worry about mathematics I'm going to talk about. It was just to illustrate how easily we can write this with this system. So for example, this theorem is called Stokes Theorem, and so it was really easy and smooth. And I'm going to make it a little bit thicker, and I'm going to show you kind of things in control I can do in this system. And it was absolutely because of this wider region, I can write it far better and easily. So let me go ahead and state this theorem. And state the theorem kind of backwards. I'm going to look at this surface integral first. And here is the vector field circle curl. And here's a normal vector dotted against it. And this is the surface integral notation. So that is supposed to be equal to the boundary line integral of the original vector fields given, but against a tangent vector like that. So I'm going to sketch the picture of the surface sitting inside 3-dimensional space. Again, making the thickness a little bit using the hotkey, and I can choose a color easily. So that's the kind of base edge surface oriented this way. So that's so let me write that one later. Again, I use the hotkey to switch back and forth quickly from the pen into the eraser. And the actual surface part, I'm going to use a slightly different color. It's just like a bubbly soap. So I'm going to write that. Thickness is changed to normal thing. So that's the surface S. So that down there is the boundary of the surface. So this surface with this edge, the bottom part here is hollow. That surface integral is equal to this line integral. So I'm going to cut out this part like that quickly. So because I need to copy that So I copied it there and change it to rectangular mode and paste it there, and I can move things around. So I just copied the edge part and replaced this weird looking surface with something simpler. So using changing the color again to the cyan one with this thicker thing in there. So I'm going to use a little bit easier surface in there. So change that to slightly thinner color. So just to give you the little bit of a 3D effect. It's just like a part of the sphere, not like this crazy bubbly shape. So let me go back to that. So I'm going to call that surface S, but it shares the exact same edge in there. So think about continuously transforming that weird surface down to something more regular, something that you can actually parameterize or something like that. So with that one, this is the Stokes theorem applied to that crazy surface, and you can apply the Stokes theorem to this one as well, where we have the common edge around it. But if you apply that, so this is supposed to be S0, so this double integral S0 in there, it's really easy to write. Like the curl F there, no effort. Because it was smaller before in the Wacom tablet, it was always a little bit of stress goes into my hand to write it properly. Now if you apply to that theorem, this value and that value is the same. The key point is that this middle part depends only on the edge of the surface and doesn't really have any information about the in-between shape of the surface in between. So if you replace it with something simpler, this value is still the same. In particular, if you had to calculate this difficult surface integral, because the quantity is the same, you could actually use for simpler surface, and that has the same edges in there. So that's the magical power of the Stokes theorem. And of course, this video is not supposed to be about Stokes theorem, but it was about using this XP Pen tablet. It's fantastic. You can really easily write this, easy to write, and especially something small, right? Small things. So you can see no practice is required. Fantastic. I absolutely recommend this product.